with the part B, right? And today is the 31st. And we have x squared equals 100. If you remember, we know how to solve this from chapter 10 by simply taking square roots. Since it's quadratic, how many solutions will I have? Quadratic means 2. Power 2, polynomial, quadratic polynomial 2. And how do I get those 2? If you remember, I could write the absolute value equals what? 10. But instead of writing the absolute value, I write something else on the other side. What do I write? Exactly. But this is not what we are trying to do now. We are trying to use factoring for this problem. So x squared equals 100. How do I proceed towards solving this? Well, I have to move 100, set it equal to 0 because I'm trying to use the zero product principle. And then I will factor. It's a binomial, it's in descending order, no greatest common factor, no negative leading coefficient. Special product. I always hope for a special product. And is this a special product? It's a difference of squares. Very good. And that's how we get x equals 10 and x equals negative 10, which we already knew from the other method. Now the next problem. Any questions here? Okay, so then 4x squared minus 18x equals 70. Remember, the key words in any math classes are factor and simplify. So this is an equation. I'm allowed to simplify both sides, and I will. And I will divide both sides by 2. I cannot divide both sides by a variable because the variable could be 0. But dividing by 2 will not change the solutions. But it will allow me to easier solve, I should say. It will be easier to solve if I divide both sides by 2. So then 2x squared minus 9x minus 35 equals 0. I have to set it equal to 0 because I'm trying to use the zero product principle. So now this is a trinomial this time. It's in descending order, no greatest common factor, no negative leading coefficient. Special product, no. 2x squared is not a perfect square, negative 35 is not a perfect square. So, and 1 is not the leading coefficient. So remember, we are down to the very last possibility. What is the last possibility? This one here. When the leading coefficient is not 1. How do I proceed when the leading coefficient is not 1? I'm trying to find two numbers whose product is, careful, careful. The leading coefficient is not 1. I have to incorporate it in the product. Exactly. So now, and the sum, indeed, that never changes. And that will be negative 9. So now you can say 70 is big, and I will have to agree. But 70 is 7 times 10. So 7 times 10, and this is 2 times 5. So I have 2 times 5 times 7. Since the product is negative, obviously one number has to be positive and one has to be negative. So one positive and one negative. And the negative number has to overcome the positive because the sum is negative. I have to use all factors, 2, 5, and 7, and come up with two numbers, one positive and one negative, such that their sum is negative 9. I presented that number 70 in prime factorization. This is the prime factorization of 70. 2 times 5 times 7. I have to use all numbers and just come up with two numbers. I will make one positive and one negative, such that when I add them, I get negative 9. Can I find two numbers? Say it again. Negative 7 and negative 2 will not give us negative 70. I have to use all numbers. Because if I use all numbers and come up with two numbers, their product will be negative 70. So negative 2 and negative 7, I'm not using 5. I can't do that because the product will not be negative 70. So let's try again. We have to use all numbers, but only come up with two. Using all three factors, come up with two numbers.
Sometimes use 14, but times 5 is 70.
Once you use all of them, you will get 70. There is no discussion there.
No matter how you arrange them.
And no matter how you arrange them.
Got it.
But give me the two numbers whose sum will be negative 9. You're on the right track. You don't have to multiply them. This is definitely negative 70. So using all these factors, 2, 5, and 7, can we come up with two numbers? And one will make positive and the other one negative, so such that when we add them, we get negative 9. Of course. Negative 14 and 5. The product will definitely be negative 70 because I used all factors. It has to be. And their sum is indeed negative 9. Excellent. How do I proceed? What will be my next step now? Yes. So 2x squared, then?
Plus 5x.
Yes, the order is not important. Yes.
Minus 14x minus 35.
Exactly. You will not make the mistake of going back to combine like terms. That will be going backwards, right? We wanted to break negative 9 into positive 5 and negative 14. And now what follows next?
Now you factor by grouping.
Good. What comes out from the first two?
Just that.
Very good. What is left in parentheses?
2x plus 5.
What should I have from the coming out from the other two? An equal symbol and 0? Mandatory?
2x plus 5.
Correct.
and the end.
Very good. And then what comes out? I need a sign and a factor.
Minus 7.
Very good. What is the common factor?
2x plus 5.
Of course. And what is left?
X minus 7.
Very good. So all this procedure was only to factor. We haven't solved yet the equation yet. So now using the zero product principle, I have 2x plus 5 is 0 and x minus 7 equals 0. What do I get from the first equation? What do I get from the second equation? I move 5 divided by 2. So x equals negative 5 halves. And I move 7, and I get x equals 7. Is that clear? Yes? Perfect. Moving on. Any questions before we move on to the next problem? Any questions? Okay. So I look at this equation, and I see that I can simplify by, not by x ever, but by 2. I will do that first. So then I have x cubed minus 25x equals 0. What is the degree of this polynomial?
3.
How many solutions do I have to write? Exactly 3. Excellent. Good. So I'm looking for and expect 3 solutions. What should I do next? Excellent. It's a binomial. It's in descending order. Greatest common factor. Yes. I can't skip any of those steps. for binomial? Is there greatest common factor? Yes? Is it? I see an x,
Okay.
right? Good. So I will factor out x. And then I have what is left?
X squared minus 25.
Excellent. But I know what to do with x squared minus 25. We have an agreement on it. What do I do with this? Is there a special product that we can use for x squared minus 25?
The difference is squared.
Indeed. Once you say the difference, and I have to have a binomial times another binomial. And one of them is
X plus 5 and X minus 5.
excellent. So now can anyone give us those three solutions? That's it. Very good. It's a zero product principle. I have zero on one side and a product on the other. So what are the options here for this product to be zero? If the first factor is 0, I get 0. If the second factor is 0, I get -5. And if the last factor is 0, I get 5. You set each factor individually, set equal to 0. Is that okay?
Yeah.
Okay. Next one. A plus 1 times a minus 5 equals 7. The zero product principle requires 0 on one side and a product on the other. What should I do first? Yes. Very good. Next step. What should I do next? Now I have 0 on the right-hand side, but I don't have a product on the left.
Multiply out the
Absolutely. Because I have to incorporate the -7, and I have to factor. Yes, very good. Thank you. So then I have a squared. A times -5 is -5a. 1 times a is positive a, and 1 times -5 is -5. Very good. Once I expand this, then I will, exactly. And then I have a squared minus 4a minus 12 equals 0. It's a trinomial. It's in descending order. No negative leading coefficient, no greatest common factor, no special product because it's -12, and 1 is the leading coefficient. So this is straightforward. I don't have to go through factoring by grouping. So how do I factor this? The product is what?
-12,
Perfect. And the sum is?
-4.
Perfect. I need two numbers whose product is -12 and whose sum is -4. Since the product is negative, I expect the positive and the negative. And the answer would be
-6 and +2.
very good. A minus 6 and a plus 2. And then I have a equals, a equals. Can anyone give us the solutions? Well done.
-2 and 3.
Excellent. That's it. We factored And we use the zero product principle, which means 0 on one side, a product on the other. Excellent. F, d times d minus 3 equals 40. How would I address this problem? What do I do here? I have no choice. So I have d minus 3 minus 40 equals 0 because I'm trying to use the 0 on one side, 0 product principle, a product on the other. What next? Very similar to the previous problem, actually. Yes, I have to. D squared minus 3d minus 40 equals 0. I know I have to factor. So I'm going to say, okay, it's a trinomial, it's in descending order, no greatest common factor, no negative leading coefficient, no special product. D is squared, but negative 40 is not a perfect square. So then, luckily, the leading coefficient is 1. I don't have to go through the long procedure. How do I factor?
Product is negative 40.
Excellent.
Sum is negative 3.
Excellent. And since the product is negative, I expect the positive and the negative.
Negative 8 and 5.
Excellent. So d minus 8 and d plus 5 equals 0. So we have two options for d. So what are the options for d?
8 negative.
That's it. Excellent. Thank you. Okay. X squared plus 7x minus 60 equals 0. It's already in descending order. It's already 0 on one side. I don't have to move terms around, but I have to factor the left-hand side. I go through the strategy for trinomials. It's a trinomial, it's in descending order, no greatest common factor, no negative leading coefficient, no special product, and luckily 1 is the leading coefficient. So there is no need for the long procedure. So I'm going to try to quickly, directly factor.
X plus 12 and X minus 5.
Excellent. X plus 12, x minus 5. Perfect. The sum is 7, so that's why the positive number is bigger in absolute value. And the product is negative 60, and the sum is positive 7. Excellent. So then we have two options for x. Remember, these are all quadratic equations, except this one. This one was not quadratic, because the degree of this polynomial is, that's why we got not 2 solutions, but 3. Good, so then x equals?
Negative 12.
Very good. Last one here, 1/2 x squared plus 5x plus 25 over 2 equals 0. And you will say, I don't like this equation. Why?
Because it has fractions.
But I can get rid of them
That's right.
because it's an equation. I don't have to keep it in. I can change it to whatever it's easier for me to work with. So what will you do to get rid of that? That's it. So let's multiply by 2 and you tell me what you get.
X squared plus 10x plus 25.
Equals
0.
times 2, right?
Yep.
Because we multiply both sides, but it happens to be 0. Good. That's it. It's a trinomial. It's in descending order, greatest common factor, no. Negative leading coefficient, no. Special product. What do you expect? I covered the middle term. What would you expect this to be?
Sum of squares.
Yes, a sum squared, not the sum of squares, but something, a binomial squared. Which binomial would you expect? That is not a trinomial. We are looking at the binomial. We have to look at trinomials.
A squared plus 2ab plus b.
Exactly. So what do you expect this to be? Without looking at the middle term.
X squared.
No, just x.
X plus plus 5.
Exactly. This is what you expect it to be. But what is the middle term here?
10.
X. Is this 10x? Is this 10x? Good. So this is the correct factored form. And I have two options. However, they are both the same. I still have to have two options because the polynomial is quadratic. It's a quadratic equation, but they happen to be the same. What? X equals? Of course, positive 5 will not give us 0, right? 5 plus 5 will not be 0. You have to solve x plus 5 equals 0. Move 5 to the other side, we get negative 5. Is that clear? Okay, perfect. Now I would like to look at some more complicated situations. So it says factoring higher degree polynomials. These are not quadratic. So these are not as easy, quote unquote. Some of the ones that we looked at were not very easy, right? So these are not as straightforward as the previous quadratic polynomials. So let's give it a shot. So 6x cubed minus 26x squared minus 20x. Mind you, these are not equations. We cannot get rid of any factor. In this particular problems, these 4 exercises, 4 problems, we are only asked to factor. So we are not dividing both sides. There is no second side or the other side. So there is only one sum or difference of 3 terms, and they are asking us to change it into a product of factors. Good. It's in descending order. Greatest common factor. I always hope for a greatest common factor. Always. Because it will make my life so much easier. Very good. Excellent. What is left in parentheses? Perfect. 2x is the greatest common factor. What is left in parentheses? Well done.
3x squared
Very good.
minus 13x
Very good.
minus 10.
Excellent. So now I'm looking inside parentheses and I'll say, this is something I know. It's in descending order, no greatest common factor, no negative leading coefficient, no special product, and 1 is not the leading coefficient. There is one more chance. If this doesn't work, polynomial inside parentheses is not factorable. So what am I looking for? I'm looking for 2 numbers whose product is and whose sum is. Careful. The leading coefficient is not 1. That coefficient has to be incorporated in the product. So therefore, the product is?
Just gotta multiply the 2. The leading coefficient and then the number on the end. So it would be 3 times negative 10.
That makes sense.
So it would be negative 10.
So therefore, I'm looking for 2 numbers, one positive and one negative. Well, how do I know that I need one positive and one negative? Because I always start by looking at the product first. So since the product is negative, then one of them has to be negative, one has to be positive. If they're both the same sign, the product will not be negative. Good. So let's find 2 numbers whose product is 30, negative 30, I should say. One positive, one negative, and their sum is negative 13. Of course. Which one is, you already said. Sorry, you already said it. Good. So we continue. Again, this is not an equation. I can't simplify or divide or anything. So I keep 2x outside. And now please tell me what to write. I use brackets because later on I will use parentheses inside, so that's why I put brackets, but it doesn't matter. You can use nested parentheses. Good. So what do I have in parentheses now? I'm sorry, brackets.
3x squared
Yes?
plus 2x
Yes?
minus 15x.
Yes. Yes. And I have to use the long procedure because the leading coefficient is not 1. Otherwise, I would have gone directly to use the numbers we got. But I can't because the leading coefficient is not 1. Perfect. So then I have 2x outside. And now I group. I don't look. When I solve problems like this, I don't cover it with my whiteout. But I literally do not look at the other two terms before I write the factored form, the common factor. So what comes out from the first two? Good. What is left in parentheses? Excellent. What has to come out from the other two? I must write it first. I may mess it up otherwise. I'm not saying that you will. You adjust the method the way you like it. I'm showing you a method, but you can contribute to it and change it the way you like. And I'm fine with it. So then I need a factor and a sign. If I omit the sign, I will not be able to finish. I will not factor. Indeed, -5. Excellent. So now I know the factor form. 2x is outside. What is the common factor inside brackets that will come out? Of course. And what else is left as another factor? That's it. We have not seen this before, right? Because this has a higher degree than 2. It has degree 3. That's why we have three factors. X from here, 3x from here, x, right? When you multiply them, you will get x cubed. And there is also a 2 in front. Okay, next problem. This is more difficult. Not because the degree is 4. Not because the degree is 4. How many factors I should come up with? Exactly. And if this were an equation, it's not. We're only asked to factor. How many solutions will I find? Right. Later on you'll see they may be real, imaginary, whatever, but 4 solutions. Degree 4, 4 solutions. Degree 10, 10 solutions. 10 factors. Maybe I can break them down into all 10, but I should have 10. Okay, now this is a totally different situation. We will encounter these type of problems in chapter 11. So we are going to practice this more in chapter 11. Here is the thought or thoughts that go through my mind when I see this. I look at this problem and I say it's a trinomial. It has degree 4, but it's missing degree 3. It's missing degree 1 because it should have degree 4, degree 3, degree 2, degree 1, and degree 0. So it's missing these 2 degrees here, and it only has the even degrees. Oh, okay. If it only has the even degrees, then what if I say, give me a letter, not X, any letter you want. You want A, perfect. I'm going to say let A be X squared. Only because I saw here degree 2 and I saw here degree 4. If I denote this by A, is there a chance that this will become A squared? If the answer is yes, and we're still talking about it, but if you say yes, you can, if you replace this by A, then you must replace this by A squared. It will be correct. Then this whole expression is quadratic. And if I stop here, you'll say, you're lying to us. Because this is not quadratic. This is degree 4. But I have to continue. In form. This will be a lie. Because this is not a polynomial degree 2. But this is correct. In other words, what am I saying to you is this. This polynomial, although it has degree 4, can be replaced by a polynomial degree 2. Only because I will use a substitution. I will say if this is A, is this A squared? Because if you say no, this is not A squared, then it's not quadratic in form. And I cannot proceed the way I would like to. But if this is A, is this A squared? It is. So then the expression becomes 3A squared minus 8A plus 5. Now you can also say, wait a minute. Your expression was given in X. All of a sudden you change it into A. And I'll say, wait a minute, when I'm done, I'm going to change it back to x. Why did I do this? Because it's easier for me, and I'm hoping for you too, to factor this after 3 hours of reviewing factoring than this, which has degree 4. Now, don't correct anything because I'm going to erase it. If I had this situation, I had nothing to do. I would have said to you, have no idea how to solve this by hand, we have to use a calculator. And it's not factorable, period. But it has 4. So if I denote this by a, x squared squared is actually the 4th. That's why this can be denoted by a, and this will definitely be a squared. So I can change this into this.
So you just simplified it before.
I didn't simplify it yet. I used the substitution and I replaced it with a polynomial that is quadratic.
Right. I didn't mean like the whole simplified ending. Just.
I changed it from degree 4 into degree 2. I will be factoring the degree 2 and then I'll go back and you'll see what happens. So now this I know how to handle. It's a trinomial, it's in descending order, greatest common factor, no negative leading coefficient, no special product, no 1 is the leading coefficient, no. I'm down to the last chance. What is the last chance? The last chance I have to factor this is to find 2 numbers whose product is and whose sum is. The product is 15, and the sum is perfect. So therefore, since the product, I always start with the product because the product gives me the indication of sign. Since the product is positive, both signs have to be the same. The numbers have to have the same sign. Now, since their sum is -8, what do I do? What am I looking for? 2 negatives. Can anyone give us 2 negative numbers whose product is positive 15 and whose sum is -8? Good. So then I continue here. How do I rewrite the polynomial? Factoring by grouping. Do not go back by mistake and combine like terms because you're not moving forward. So from the first 2, what will I factor out? And?
3.
Very good. What is left in parentheses? Yes? Perfect. What should I have from the other 2? Mandatory, otherwise I can't continue. And I know they're there. Or this factor is there. Good. And in front? Excellent. So then I have a minus 1 is the common factor, and what else is left? What is the other factor? Very good. Perfect. However, the expression is given in x. So now can you tell me what is this in terms of x? What did we denote by a? What did we say let a be?
It was their a squared. So
One more time. A is only one thing, not 2 different things. What did we denote by a? No, a cannot be x. I would not be able to change this into a quadratic. It's right here. A is x squared. Just one quantity, not 2 different quantities. A is x squared. So now I can go back and replace a by x squared. So what is the expression now after I go back?
X squared minus 1
Very good.
and 3x squared minus 1.
Excellent. Although the second one I don't know how to factor, it's not factorable using integers, I do know how to factor the first one. How do I factor x squared minus 1? It's a binomial, it's a special product. We used it at least the third or the fourth time today. Correct. Perfect. How do I factor this?
X plus 1 and x minus 1.
Very good. I don't know the other one because it's not, I don't have, 3x squared is not a perfect square and negative 5 is not a perfect square and they're not perfect cubes, so that part stays as is. Very good. Next one. Any questions on this? So please remember this is quadratic in form and this is the method of substitution. It will come back to in chapter 5. So method of substitution. We substituted x squared by a. You can use any letter you want. You don't have to use a, but you cannot use x because x is in the problem already. Perfect. We'll come back to more examples of that very soon. Okay, so now this is 4x to the 4th minus 64, has degree 4. We are only asked to factor completely. Okay, it's a binomial, it's in descending order, greatest common factor. 4, very good, excellent. What is left in parentheses? Very good. Now I look at x to the 4th minus 16, I know it's a binomial, and I know there is a special product, either difference of squares or difference of cubes. So is there any way I can factor this? Excellent. Good. What do I get? Very good. It's x squared minus 4 and x squared plus 4 first. Can I factor x squared plus 4? It's the sum of squares, which is not factorable. Can I factor the difference of squares, x squared minus 4? Yes. How?
X minus 2 and x plus 2.
That's it. And this is the complete factor form. Now, a few minutes ago I said if the degree is 4, I have to come up with 4 factors. But, of course, 4 is just a number. So I don't have 4 factors here. I have one factor, which is x minus 2. I have another factor, which is x plus 2. But actually, I have 2 here. But I cannot factor them because it's degree 2. This should have 2 different factors. It has 2, degree 2. So degree 2 times degree 1 times degree 1 will be degree 4. But since I cannot factor this one, if I'm asked to solve, I will still get 4 solutions. Because from here, remember, I can solve this, x squared plus 4 equals 0, take 4 to the other side, it's a negative number, and I get the number I. Okay, last one here on this page. 6x to the 5th minus 47x to the 4th plus 35x to the 3rd. Let's see what we do with this. And then we have the second page, the last page with equations. And then we can start chapter 11. Okay, what is the degree of this polynomial? Yes. Good. So degree 5. I should have 5 factors, but here I had degree 4, but I had 2 in here, 3, 4. So we'll see what we come up with in this case. Good. It's a polynomial, 3 terms. It's in descending order. Greatest common factor? I definitely hope so. What? Very good. Good. What is left?
6x squared
Very good.
minus 47x plus
Very good.
35.
Excellent. Okay, now I'm in known territory, right? It's degree 2. It's in descending order, no greatest common factor, no negative leading coefficient, no special product, because 6x squared is not a perfect square and 35 is not a perfect square. 1 is not a leading coefficient. I have my last chance. What do I mean by the last chance?
Find numbers whose product is
Don't multiply, just tell me which of times is. I'll show you why.
6 times 35.
Exactly, and I'll keep it like this because it's so big, the number is so big, I'm going to use prime factorization as we did with 70.
Okay.
So there is no point in multiplying it. Those two. And whose sum is?
Negative 47.
Good. Since the product is positive, both numbers have to have the same sign. But now since the sum is negative, I know exactly which sign they have to have. Which one? Both negative. Very good. Okay. I take 6 times 35 aside. 6 times 35. 6 in prime numbers is 2 and 3. And 35 in prime numbers is? Perfect. We need to use all factors and come up with two numbers whose sum is 47. Or if you can say two negative numbers whose sum is negative 47. So let's think. Think of all possibilities. Let's take a minute. Group them. Jump over them. Whatever. But everything has to be accounted for. 2 has to be used. 3 has to be used. 5 has to be used. And 7 has to be used. But only give me two numbers. You can write the alternatives on the side. Like, for example, I would write 6 times 35 does not work. I will write 2 times whatever you want to say, the whole thing. So 15 or 14 times 15, not good. Because the sum is not 47. Then you can say jump over and I say 10 times 21. That's not good because the sum is not 47.
3 times 7 times 2.
Exactly, which is 42. And the last one is 5 by itself. Excellent. Indeed, 42 and 5. So these all three are together and this is alone. Excellent. Wonderful. So now we're in business. So let's go back. What will I write? Of course, x cubed has to be there. It's waiting for me outside patiently. But now I have to rearrange what I have in parentheses. So what do I have there? A 6x squared, a negative 42x, a negative 5x, and a positive 35. Would you agree?
Yeah.
Good. So what do I pull out from the first two? Perfect. What is left in parentheses? Good. What should I have from the other two? Mandatory. I know it's there because I found the numbers. Otherwise, I would have worried about it, but I found the numbers. I know it's there. And I need the sign and the factor. Of course. So then I have x cubed as the first factor. What will be the next factor? Of course, the factors can be presented in any order you want, because it's not going to make any difference. So x, indeed, yes. Now you can say, well, in this chapter, in chapter 11, you're going to show us another method that will be much easier than this. However, knowing factoring, it gives you some power. You're going to solve problems like this versus thinking, okay, what is the quadratic formula? How do I do that? And so on and so forth. It's a good technique to know in all your math classes, everything that follows from here on. Okay, last page. I want to solve some equations that have a higher degree. Okay? So let's take a look. Y cubed minus 3y squared minus 4y equals 0. So the degree of this polynomial is? Very good. How many solutions do you expect? Yes. It's a polynomial with 3 terms. Greatest common factor? Perfect. What is left?
Y cubed.
Y squared.
Okay, y squared minus 3y minus 4.
Good. Again, we are back to known territory. Y squared minus 3y minus 4, it's in descending order. No greatest common factor, no negative leading coefficient, no special product, but 1 is the leading coefficient, so I will go straight ahead to factoring it. So y, and then write 3 solutions. So how do I factor y squared minus 3y minus 4? Perfect. Perfect. Since the product is negative, they have to have opposite signs. Very good. So y minus 4 and y minus 1. Can anyone give us 3 solutions, please? You don't have to jump over this. If this is 0, then y is 0. Perfect. Any questions? Okay. X to the 4th minus 36x squared equals 0. How many, what is the degree of this polynomial? How many solutions we expect? 4. Perfect. It's a binomial. It's in descending order. Greatest common factor? Excellent. In parentheses. What does this mean? X squared minus 36. This is over and over the same thing. Difference of squares, which is? We expect how many solutions again? Some of them may be the same. We don't care. We still have to present 4. Can anyone give us 4 solutions? How many times? Yes. You will see what this means in the next course. In the next course, when a solution appears twice. Sorry, forgive me, I was talking at that's it. 4x to the 4th equals 100x squared. What is the degree of this? How many solutions will we get? 4. But this time it's an equation and I can divide not by a variable, but I can simplify both sides by and divide both sides by. No, not variable. Because if I divide by x squared, I will not present 4 solutions anymore. I can divide by a number. That's not going to affect the answer, but I cannot divide by x. So this is x to the fourth equals 25x squared. Of course, I want to use the zero product principle. What do I have to do first before I get to that stage? And of course, I need to factor after that.
25x squared.
Of course. So x to the fourth minus 25x squared equals 0. What now?
Factor out x squared.
Yes. You understand why x squared has to be in the problem. Otherwise, those two solutions will go away. And I will not have 4 solutions as I expect. That's why I'm asking you, before we touch the problem, I'm asking you to realize how many solutions you have to write. Just in case we are tempted to do something we're not supposed to. At least in the back of our minds, it's clear we are expecting 4 solutions. Good. What is in parentheses?
X squared minus 25.
Very good. And what do I do with that?
It's the difference of squares.
Perfect.
So it'll be x squared, x plus 5, x minus 5.
Good. And 4 solutions, please. Two of them are the same.
X equals 0, and then column of 5 and negative.
Very good. B cubed equals -1.